Okay, so now I'm going to just look at greatest common factors. So the very first thing that I need to do is I need to factor these. So this is how I do it. If you work out your own method, it's totally fine. You can still use the T-chart as well if you want to. But this is how I do it. So 22 divided by 1 is 22. 22 divided by 2 is 11. Okay, then by 3 doesn't work, 4 doesn't work, 5 doesn't work, 6, 7, 8, 9, and 10 don't divide into 22. So I know I'm done. So 33, I have 1 and 33. 2 doesn't divide into 33, 3 does, 4 doesn't, 5 doesn't, 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 doesn't, and I know that I'm done. Okay, 75. So 2 does not divide into 75, but 3 does, and that's 25. 5 divides into 75 15 times. 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10, 11, 12, 13, and 14 don't. Okay, so 1 and 90. So 90 divided by 2 is 45. 90 divided by 3 is 30. Still working systematically, right? 4 doesn't divide in, 5 does, and that gives me 18. 6 does, and that gives me 15. 7 doesn't, 8 doesn't, and 9 times 10, and I know I'm done. Okay, now I'm going to find the greatest common factor. Okay, so I'm looking at 22 and 33. 22 doesn't match, but the 11s do. So I know that the greatest common factor is 11. If I'm looking at 33 and 75, clearly 75 is too big. So 33 is not there, 11 is not there, 3, but 3 is in both factorizations. So 90, again, 70 and 75. 75 is not in 90's factors, 25 is not, but 15 is in both. So I know that 15 is a factor, the greatest common factor. And notice that I'm starting from the largest number and moving to the left there. So greatest common factors between 33, 75, and 90. So I'd like you to pause the video and find it yourself, and then start the video when you've got it. Okay, so looking here, because I know 75 and 90 clearly are not going to be the common factor, the greatest common factor. 33, 11, no, but 3 is, and that is the greatest common factor between 33, 75, and 90. Okay, so now we are going to make a generalization based on consecutive numbers and the greatest common factor. So we're going to make a generalization that we can kind of say is a rule if we tested it enough. All right, first we're going to look at 14. So 1 and 14, 2, 14 divided by 2 is 7. 3 doesn't divide in, 4 doesn't, 5, and 6 all don't. So I know I'm done. Okay, 1 and 15, and I know the factors of that are not 2, 3, and 5 are, and 4 is not. So I'm going to look, and the only ones that match is 1. Okay, and again, let's do 27. And so 2 doesn't divide into 27, but 3 does, and 9, 4 doesn't, 5 doesn't, 6 doesn't, 7 or 8 don't. So we are finished there. And 28, okay, 2, that's 14, 3 doesn't work, 4 works, and that is 7. 5 doesn't work, 6 doesn't work, So we're done there. So if I'm looking at this, you'll notice that there's no factors that match but one. Okay, and again, 1 and 34. Hopefully I have enough room there. So 34 divided by 2 is 17. 3 doesn't work. 4, 5, 6. Actually, there are no other factors, so I'm just going to move those over. Okay. All right. If you leave big spaces, I will not care. All right. So 1 and 35. I know 2 doesn't, 3 doesn't, 4 doesn't, but 5 does, and that's 7, and I know that 6 doesn't work. All right, without giving me a decimal there. So again, the only ones that match up are the ones. So that's the greatest common factor is 1. So what is the generalization that I can make from my work here, my testing? So what I see is, this is what I'm going to state. When you have two consecutive numbers, the greatest common factor will always be 1. And I can continue on and check bigger numbers and stuff to see if that's true. But that's my generalization right now. And if I continued on and did multiple examples throughout, I could say that that would be a rule. Now, on your worksheet, what you're going to do, okay, is you are going to find the greatest common factor for some consecutive odd numbers. And then you're going to do, so at least do 3 different groupings like we did here, at least 3. But I want you to make a generalization. So do at least 3 consecutive odd numbers right here. Okay, I don't need to rewrite that. It's also on your paper. And then I want you to make a generalization from that. Okay?